How to interpret label ranking average precision score. I'm new to array programming and found it difficult to interpret the scikitlearn.metrics label _ranking _average _precision score function. I need your help to understand the way it is calculated and appreciate any tips to learn numpy array programming. Generally, I know precision is true positive plus false positive. The reason why I'm asking is that I stumbled upon Kaggle competition for audio tagging and came across this post that says they are using wrap function for calculating the score when there are more than one correct label in the response. I started to read to know how the score is calculated and found it difficult to interpret. My two difficulties are: 1. Interpreting the math function from documentation. I am not sure how ranks are used in score calculation. 2. Interpreting numpy array operations from the code. The function that I am reading is from Google Colab document, and I tried reading the documentation at scikitlearn but couldn't understand properly. Code for one sample calculation is:
To better understand how the score is calculated, let's come up with a simple example. Pretend we are labeling images that may contain cats, dogs, and/or birds. The class array looks like cat, dog, bird. So if we have an image containing only a cat in it, the truth array will have the form 1, 0, 0. We feed the model this image containing only a cat and it outputs .9.2.3. First, we rank the labels that the model predicted. Cat got first place, bird got second place, and dog got third place. Now we count how many labels it takes to get to the true class of interest, cat, starting at first place. The model had cat in first place, so this simply takes a value of 1. Next, we count how many other true labels there were until we reached the correct label, cat. This may seem confusing at first, but it will be necessary for the multi-label examples later. For this case, the cat label was correct and we didn't need to move any further, so this also takes a value of 1. The score is calculated by taking the second value and dividing it by the first value. In this scenario, the score is 1 1 equals 1. So what happens if the model gets it out of order? Let's put that same cat image through a different model. It outputs .6.8.1. Rank the labels from first to last. Dog got first place, cat got second place, and bird got third place. Find out how many labels it takes to get to the correct class of interest, cat again, starting at first place. For this scenario, it takes 2 labels, so the first value is 2. Next, figure out how many correct labels there were along the way. There was only 1, so the second value is 1. For this case, the score is half equals 0.50. Alright, so those are the simple examples. I'm not going to be as verbose for these next 2, but apply the same logic as above. The main difference is that each correct label needs to be calculated separately. Correctly ranking 2 labels. Image contains a cat and bird. 1, 0, 1. The model outputs .8.2.9. Ranking is bird, cat, dog. For the cat label, The first value is 2, took 2 labels to get to it, and the second value is 2. There were 2 correct labels along the way, bird and cat. Score equals 2 halves equals 1. For the bird label, the first value is 1 and the second value is 1. Score equals 1 1 equals 1. Incorrectly ranking 2 labels, image contains a cat and dog, 1, 1, 0. The model outputs, .1, .2, .8. Ranking is bird, dog, cat. For the cat label, first value is 3 and the second value is 2. Score equals 2/3 equals 0.66. For the dog label, first value is 2 and the second value is 1. Score equals half equals 0.50. Okay, so how do we get the final score for each class? The simplest way would be to take an average. Let's use the previous 2 examples to calculate this. For cat, we had scores of 1 and 0.66. Final cat score equals 1 plus 0.66/2 equals 0.83. For dog, we had a score of 0.50 only, so final dog score equals 0.50. For bird, we had a score of 1.0 only, so final bird score equals 1. This metric is great for analyzing class performance. How can we compress these class scores into one final score? We could just average all of the final class scores, but this would dilute scores of common classes and boost less frequent classes. Instead, we can simply use a weighted average. Using the 2 example images, we had 2 cats, 1 dog, and 1 bird. Final score equals 2 cats/4 labels, 0.83 plus 1 dog/4 labels, 0.50 plus 1 bird/4 labels, 1.0 equals 0.79. Conveniently, this ends up being the same as averaging all of the individual scores, so we don't even need to store class weights. Recall that we had individual scores of 1 and 1 for the cat and bird of the first image and then 0.66 and 0.50 for the cat and dog of the second image. 1 plus 1 plus 0.66 plus 0.50/4 equals 0.79. Hopefully this gives you a better understanding of the calculations. I'll leave the code to another poster as I have droned on long enough. Perhaps if no one answers that portion soon, I can add a write-up.